afternoon, everyone. We're going to go ahead and get started today. So, here's the things that we're going to look at today. We're going to review Printf. We're going to go over that in-class assignment we did on Thursday, kind of talk a little bit more about it. Talk about variables, talk about how we can use Printf to change the formatting of certain outputs. We're going to talk about the first assignment that you'll have in this class, and talk about the in-class assignment and work on the in-class assignment that will be due at midnight today. So, getting started, remember this is the basics of Printf. So, anytime Printf sees one of these format identifiers, as we would call them, inside our format string, as we would call this. So, this right here is a format identifier. This is a format string, which contains format identifiers. So whenever we see one of these format identifiers in our string, we're going to look ahead. We're going to find, let's say we see our first format identifier, we're going to grab this first item and we're going to replace it here. So this hello is going to replace this %s. Then we're going to see our second format identifier, and then we're going to replace it with this a in single quotes, and so on and so forth. So remember that for every format identifier we have in our format string, we need to specify what we want that to be replaced with after the commas in our list. And we also have to make sure that our types match. So if we specify a string, we have to say %s. If we specify a character, like this, we have to say %c, and so on and so forth. So I'm just going to go through. We'll open this up. I'm sure it has something in it. So going at this again, so if we have a single, let's say, did I use %? Yeah. So let's say we have a single number we want to print off. So remember that we can say, we provide the format string, so this is a %i, this is where the number is going to be replaced into. We can say \n, which will take the cursor and take it down to the next line, and then we can specify the number that we want outputted here. And that will output 10. So remember that we, again, have to make sure that we're outputting the right type. So if we said, let's say, %f to output a decimal, that should give us a warning. Yeah, it will say, warning, format %f expects a argument of type double. And we'll talk about what double means actually later today. Again, worth noting that I'm using the Vim editor just because I'm more familiar with it. But again, when you probably are just starting out here, you want to probably just use nano. So again, you just say nano, and then your file name. And then Control X to exit out of it. If you've made any changes, it'll prompt you to save, push Y, and then enter, I believe, and it will save the file. But going back to this, so that gives us a warning. So again, your format identifier needs to match the data type that you're providing it. So if we change this to like 10.1, then it would be fine. So that's fine. And then as we add more format identifiers in our format string, we again need to specify additional parameters. If we specify 2 format identifiers, we'll only provide 1 additional parameter. And when I say parameter, I mean everything. Let's add another one here. So this is the first parameter, and this is the first format identifier. So we're going to replace the first format identifier with the first parameter. And then this is the second parameter. So we're going to replace the second parameter with the second format identifier. So going back, this is what I was going to talk about before. If we specified too many format identifiers in our program, but we don't specify what we want to be what we want those format identifiers to be replaced by, again, that's going to give us a warning. Now again, when we say warning, that means that the program's still going to run. So if I run a.out, it's actually going to run, and it's going to give us some output. But the output of the program, after the compiler is given a warning, is what we would call undefined. We don't know exactly what's going to happen, but that's not really important right now. What is important is for every format identifier you specify, again, you need to say the number that you want outputted or the data you want outputted, and you need to make sure that you have the correct format identifier. So looking at our assignment from Thursday. So that was create a C program which prints out a string, character, an integer, and a floating point number. So using all of these different format identifiers, just create a simple program that does that. So there's two ways you could accomplish that. You could either say printf, so %s for string, %c, %i for integer, %f for floating point number, then a /n to go to the next line. And our first parameter is, let's just say ASDF, second is A, third is 10, and the final is 10.1. And that would be one way of completing the in-class assignment. The other way is to write a printf for each individual item that you want printed out. So you could say printf %i space and then 10, and then write another printf and say 10.1, and so on and so forth. So you could either have all your printfs on one line, or you could have them on multiple lines. It ends with the same result. So that was the in-class assignment. Any questions on that or anything else with the printf stuff that we talked about on Thursday? All right, so we're going to move on to some more stuff that you've probably seen in your reading so far. So we're going to talk about declaring variables. So when we declare a variable, we essentially name a location in memory that we can store values. So in order to declare a variable, what we need to do is say what data type we want, and then what name we want to give the variable. So when we had an integer, we need to say int, which is the data type we use to declare an integer, and then the name of that variable, so int my int. And then if we want a character, we say char my char. And if we want a floating point or a decimal number, we need to say double my float. You can also say float my float, but for some compatibility issues, we normally want to say double. We'll talk more about that later, but not really important right now. So when we declare these variables, they essentially contain nothing. So let's say we wanted to declare and assign the variables a value. So we would say what data type we want them to be, what their name is, and what their value should be when they're declared. So we could say int my int and equal to 1, and we'll store 1 into my int. So when we're talking about variables, so let's go back over to our printf example here. So this right here is what we would call a literal value. So anywhere that we can put a literal value, we can also put a variable. So let's say we go up here and we declare an int my int. And we give it the value 10. Or for this example, let's give it 20. So we can take this variable and we can put it right here. Compile the program. And we'll see the program is going to output 20. So you can either put a literal value, like we had 10 here before, or you can put a variable value, like this. So going back, let's say we wanted to declare a different type. Let's say we wanted to also replace the literal value in the second printf. We could say double my float, or let's just say my decimal, equals 10.1. And we could replace that with my decimal, just like that. So again, anywhere that a literal value would be expected, you could also put a variable. And the value that's contained in this variable will be substituted for this format identifier in our format string. All right. So then we can talk about reassigning variables. So after we've declared a variable, we can change its value later on. So go after our printfs, we can say my int equals 30, and then we could just go ahead and print it off again. So I'm going to go back here again, and I'm going to add new lines. So after each number that's printed, we're going to again take the cursor and bring it down to the next line. So let's just print out what my int is. So we could say my int is %i, a new line again, and then print out my int. So, again, what this is going to do, it's going to take the value that's stored in my int, and it's going to replace this %i with that value. So what we're doing here on this line is we are assigning the variable my int the value 30. So it previously had the value 20 when we first started out, and we printed out that value right here on this line. This is the key I want. Nope, that's not the key I want. On this line right here. And then we reassign the value down. So running this program again, you can see it starts with 20, and then we reassign the value to be 30, and then we print it off again. So this is something a little bit different than we've done before. We haven't had text in our format strings, so it is worth noting that you can specify literal text here in your format string, and then just the values will be replaced. So we could change this up here and make our output be a little bit more understandable to understand what our program's doing. So we could say my int starts at, and then it will print out the value that it's originally put at. And then we could say my int is now, and the value that will be stored in my int. Alright, so we did get a warning now, and that warning says unused variable my decimal. So what happened is when we ran GCC, it detected that there was a variable that we never used. So you see we have this variable my decimal, and it's never used anywhere in our code. So I'm just going to delete that to get rid of the warning. If you ever see that, it's not really important, but it does matter if you did spell something wrong. So I might have done something like this. So let's go back. Let's say let's redeclare that. So double, which is the data type, and then the name of the variable, which is my decimal, equals, let's say 10.1, and then let's write another printf to print that out quick. But instead of spelling our name correctly, we're going to say my float, or we're going to name some variable that we haven't actually declared yet. So let's see what happens when that is run. So the first, well actually we get a couple different things. So this first one is, it says warning implicit declaration of, this was supposed to be printf, but you can see that that was clearly, I clearly typed that wrong. So go back in here and change that to be correct. So that fixes our first warning. So we do have an error here, and it says my float undeclared. So when we use variables for the first time, we have to name them for the first time. But that wasn't the error that I made in this case. The error that I made in this case is that I referred to my float instead of referring to my decimal. Now we can troubleshoot that by looking at the warning that comes further on. And that warning says unused variable my decimal. Now the whole point of the compiler notifying you that a variable is unused is if you are allocating, if you're naming that space in memory and you're never putting anything into it, the compiler is going to think that something was wrong, because you wouldn't just allocate memory, or you wouldn't name that memory, create that variable for no reason. So if that it was my error, I would go back and I'd change that to be my decimal. But that was more of a tangent than anything. But again, talking about our format strings and how we can have literal text like this, and we can have variable values that can be replaced, like my int. Compile this one more time and run it. So our program will say where my int starts at, which is 20, and then it will tell us where my int finally, the final value of my int. So that is variables. Any questions about variables right now? And the simple assignments that we can do on them. So we can continue on with this example if we wanted to. We could take my int, we could reassign it as many different times as we wanted to, or we could reassign it none at all. Just remember that anywhere where a literal value would be expected, like 10, we could either specify a literal value, or we could specify the actual variable that contains a value. So that's that. And then the next topic I wanted to talk about today is printf decimal formatting. So going back over here, let's clear all this out and start over here. So let's declare a variable. We'll just call it A, and we'll set it equal to 5.5. And then in order to print out a double or floating point number, we need to say printf. We'll say A is %f and print out a new line, and then we'll provide A to be substituted for this %f. Now when we compile and run that program, it's going to say A is 5.5, and then it's going to provide us 6 decimal places in our output. So count them 1, 2, 3, 4, 5, 6. Now when we specify %f by itself, it's always going to output a decimal number with 6 digits of precision. So looking over here, we can control the amount of precision in our output. So we can say between the % and the f, we can say 0.5 to only print 5 decimal places, or 0.2 to only print 2 decimal places, or I think we can even say 0.0 to print no decimal places, or maybe the least we can do is 1. I'm not exactly sure. But let's say we wanted to take this and only print out the number of decimal places that we have in our number. Can anybody suggest what I should type in here between the % and the f? Here, I'll do this example again. So, in order to print 5 decimal places, I'd say %.5f. In order to print 2 decimal places, I'd say %.2f. What would I say to print 1 decimal place? 0.1. Yep. So when I recompile this program, or I save the program and recompile it, we can see that we're only going to output 1 decimal place this time. So that's kind of useful. You should keep in mind that you can control the amount of decimals. I'm just going to test this really quick. I don't remember if I can do this. See if I can print it with 0 decimal places. Yeah, I can in fact print it with 0 decimal places. So if you had a floating point number that was contained a decimal number, then you could also print it with 0 decimal places. So there's also another component to this. Let's see here, I changed that. 0. There's also one more component to decimal formatting. You can also tell printf how long the output should be in total. So you can say %10f to output a total of 10 characters, and that will be left padded with zeros, or it'll be left padded with spaces in this case. So taking this number, we have 5.5. I can say 10. Well, here's what we'll do. We'll output it the way it is by default. So we'll output it with just %f, and then we'll output it with %10f. So looking at that, we can see it's aligned a little bit differently now that we said %10f. So starting right here, let's count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we say %10f, that means we're going to print a total of 10 positions out. We could shorten that if we wanted to. Let's say we only wanted to print 5 positions. And let's just see what that does. So if we specify less than the total length of the string, it's going to print the string, I should say output. If we specify a number less than the output, because we have 6 digits here, 7 including the decimal, 8 with the whole number component, but we specified 5, so we can only specify numbers bigger than the total width. So again, let's say we wanted to go something really big and say 20, so we wanted that number to be 20 total wide. When we outputted it, we could do that if we wanted to. So another interesting thing, I guess, is we can change what character we pad it with. So right now we're padding it with spaces. So we put spaces on the left to get it to be 20 characters in total. So we could change it to be 020. So instead of printing the spaces like we printed before, we would now print zeros instead. So all these spaces will be filled with zeros. And I don't remember quite if you can change it from anything other than 0, but the only thing you would ever really need to use is either space padding or 0 padding, so that's all I'll talk about right now. So you can also combine both padding and precision. So when we say something like 0.2f, that's going to print our decimal number with a precision of 2 decimals. So when we say 20f, that's going to print it with a padding of 20 decimals. So it's going to pad it, or not 20 decimals, 20 characters. So it's going to pad it so it takes up 20, it's going to take up 20 positions. But again, we can combine those two, and we can say, let's start off, we'll print just 0.2, and then we'll print 10.2f, and see what the difference is between those. So we can see that when we control the precision, there's only going to be four places outputted by default. So we have 1 right here, 1. That's not what I want. I want to select 1, 2, 3, 4. So in order to get to those 10 character outputs that we specified, we need to print out 10 positions. So starting right here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you might be asking yourself why any of this matters, and it's a good question. So let's say we had different numbers of different sizes. So let's add another number. Let's say double B equals 100.5. So let's take this same expression here, this printf command, and we will say B is, and instead of saying A, we'll say B. So what this first printf does is it prints off A, and what the second printf does is print off B. So going back, recompiling the program, we can see that this is useful because it allows us to line up numbers of different widths. So if we weren't to say, let's go back here again, I'll take both of these lines, and I will print them out without the padding specifier. I'll leave the precision specifier, so we'll only print out 2 decimals, but I will remove the padding specifier. But we'll still keep the original printf, or the originals. So basically what that allows us to do is it allows us to line up the decimal places with numbers that are of different, I guess, whole number widths. So something to keep in mind. So that is precision and padding. So that was the example of combining both precision and padding. So this is going to be the assignment. We're going to talk about that in a second, but I wanted to talk about one thing before that. So I did talk about declaring, I just want to go over this one more time actually. So declaring that's a decimal. So this is a integer. So integer is a whole number. Remember, it can only be a whole number. We can only specify a whole number here. For a double, we could specify a whole number here. It's optional, so we could say double A equals 10. That's also valid, but you can't take a decimal literal here, and you can't do this. You can't say 5.5. You can't do that, or at least you really shouldn't, because it doesn't make any sense. You might be allowed to do it nowadays, I don't remember exactly for sure, but don't do it. That's all that matters. So, and then finally, the last one we talked about was char, so we'll call that char C. And remember, when we are storing a character, we need to put that in single quotations. So let's put an @ sign in there, and that will store the @ into this C. And then finally, because I didn't talk about it today, was how you print off a single character. So you can say %C, and then a new line, and then C. And all this program will do, I'll delete all these other things, but it will just print off a single @ sign. So that prints off a single @ sign. So a couple other things, just going to go over the kind of terminal controls again, the helpful hints. So again, remember you can push up and down to navigate through your terminal history, or you could press Control-R and start typing the command that you typed before. So I'm at my main prompt right now, and I press Control, hold down Control, and then press R. This reverse search will pop up. And let's say I wanted to search for the last GCC command I had, so I could say GCC, and then I could just hit Enter, and it would run that command. Or I could press Control-R, and it would search through the rest of my history. Now, there's nothing in my history right now, but just thought I'd remind you of those terminal commands that you can use again. So let's go back. And one last thing before we talk about the assignment and move on to the in-class assignment. I can specify variables as many times as I want to. So I can say CC like that. Or I could do like %cc. I could just keep expanding it forever and ever and ever if I wanted to. So all that matters is the first C, whatever this value is right here, will replace the first format identifier, and so on and so forth. So looking at this one more time, we can see that there is 3 @ signs printed out. So that's that. So talking about our assignment. So this is going to be the first assignment that I'll have you do. So in this assignment, it's annoying me. This is really annoying me. Okay. So in this first assignment, I want you to declare and assign 3 integers, floating point numbers, and characters. So output 1 variable of each type on 3 lines, and then output 3 variables of 1 type on a line 3 times. Assign all the variables new values and output them again as described above. So what that will end up looking like is this. So later on I go and I say your variable name should be unique. So you shouldn't have the same variable names as anybody in the class. So think of random words you wanted to use. So let's say you're in this program, you're writing it. You should be like int banana, or give it interesting names like that, or think of things that will differentiate your program from other people in the class. Don't think about it too hard, but you should try and have different names as much as possible. So the values you assign should also be unique. So just think of the most random numbers that come off the top of your head, and they should be fine. And then floating point numbers should be outputted with a precision of 2 decimals. So that's one of the things we talked about today, was outputting floating point numbers. So you need to say %.2f when you're doing this. And then finally, you can run /dist/assignment1 to see a program which provides the sample output. So in order to do that, what I would say is /dist, then assignment1. And remember, you can press tab to complete file names. So when I run that, it will output the sample output just the way that I would want you to have outputted it. So that is assignment 1. Any questions on that right now? All right, so then finally we are going to move on to the in-class assignment. I'm going to sneak in really here quick and change it to day 3. So the in-class assignment for today is to declare an integer, a character, and a floating point number. Assign each of these variables a value, either when you originally declare them or afterwards, that's fine too. and then output each of the variables to the terminal with printf, and then submit it to day 3 in class. So, have at it, I guess. Any questions? Just raise your hand or yell at me, or yeah, that's all we'll do. So we'll work on that today. Some things I did I did forget to cover a couple other things that I wanted to go over. So we'll talk about that. So this is our class right here. Remember that if you want to go over any of the content that we've talked about in class, there's kind of 2 ways to do that. So you can go to content, and then I will try and post the PowerPoints and any other documents that you might need. You'll find the assignment 1 in week 3 right here. You'll also, hopefully, I'll post the PowerPoints as soon as I get to them. If you do go into a week and you realize that I didn't post a PowerPoint, or you think I'm missing some content, just send me an email and I'll try and get that up as soon as possible. Otherwise, if you want to listen to the lectures, you can always go to the videos link right here, and that will contain all of the videos that I've uploaded. And I should usually get those videos uploaded by like about 6 every day after the lecture. And if I, again, forget to upload a video or something like that, just send me an email, poke me or something, and I will get it uploaded. And then finally, talking about the reading assignments, completion looks pretty good right now. I will be pulling, I did pull that data at 12, I think. So I'll be figuring out exactly how I will be putting that into D2L pretty soon. But so again, the assignment was to read through section 7, I believe. That's judging by completion. So yeah, I'll be pulling those grades in pretty soon. You should see the first daily assignments also graded. So if you go over to grades, you should see day 1 and day 2, and you should have a point for that if you completed it, or not a point if you did not complete it and submit it. So that's that. Any other questions before we get started on the in-class assignment? All right, I'm going to stop the recording quick, then I will bring it back up.